Good day. Now we have studied processes, first law of thermodynamics and cycle. Today we are going to study very important section. What is that? Heat engines and cycle. After that, second law of thermodynamics. Okay, we'll see. Look at the figure. What is it? It is an engine. Then you look at the figure. You remember or you identify the one point within the figure as commencing point, whether a spark plug lighting point or any other point, up to you. So then wait until the same point is reached after the rotation. So it completes because one cycle, and that is to be repeated over and over again to run infinite number of or infinitive number of revolutions. So important thing is the identification of the cycle. So we can produce an engine that operates in a cycle. It is clearly understood. So another important thing about this cycle. What is it? So now already you have observed the starting point of each cycle. Then at this starting point, there is a particular internal energy belongs to that starting point. The same internal energy you can observe for the next cycle when it commences. Remember, you should not select different points for same cycle. That is important. That means your datum or the reference for the starting. Okay. You have many questions now. And sometimes you think it is as a mesh. Don't worry. This is an engine. You will study all these things later. Simply what you should remember is, you have a cycle, there is a starting point, and that starting point is regained after completing 2 or 3 or 4 or the number of processes generally. Then you can define a cycle, and same cycle is repeated over and over again until your machine stops. That is what you should remember. Okay, now we are going to study second law of thermodynamics. Second law. What is the second law? How do we relate the second law with our knowledge that we have gained up to now? Shall we going to relate it is like that? So can you remember? You can remember our diagram, system diagram. The state 1 reached to state 2 and again return to state 1 with a cycle in the figure. So during that cycle, heat can transfer, work can transfer as shown in the figure what you have studied. Once this cycle is taken place, really what is happening? So we have to think of this system concerning the heat quantity and work quantity. That is what we are going to study with second law of thermodynamics. What are the options we have when this cycle is completed? State 1 reached to state 2, again state 2 reached to state 1 within the cycle. During that cycle, while it is taken place, heat transfer could be taken place, work transfer could be taken place. So, with this system, what are possible? What are the events that are possible? Then, together with this system, when heat is supplied, you can identify that heat quantity when it is supplied as a hot heat sink or hot area of having heat. So we can identify it as a hot reservoir. Okay? So then hot reservoir, from hot area you supply heat to the engine within the cycle or within the system. Then one possibility is whole heat could be transferred into whole work. But with your understanding, with your advanced level knowledge and the prediction and due to many parameters, irreversibilities, you have studied all the reversible processes and irreversible processes, ideal conditions, real conditions. Based on that, you will understand that is impossible. The whole heat you can't convert into whole work. Something like that. Then what is the another option you can have? You have hot reservoir because your Q, where the combustion, some example where the combustion is taken place. Then from the out of the combustion, little bit of heat could be transferred or rejected. It is possible. Then you can have the hotter area where the combustion is taken place and another area where the heat is rejected. That means you can have a hotter area as well as cold area. In technically, you can say hot reservoir and cold reservoir with terminology used in thermodynamics. Okay, then what is possible? Then you with your supplied heat, certain amount will be rejected and part of that can be converted into work. That is possible. I think basically you understand what are the possible events that could be taken place when a cycle is taken place within a system. Okay, we'll see what happens next. Okay, now we have reached to our objective. We are going to state second law of thermodynamics. What it states? It is impossible for a heat engine to produce a net work output in a complete cycle if it exchanges heat only with a single energy reservoir. How do I understand this sentence or this definition? Belongs to second law of thermodynamics. As you have studied in previous two slides, you can have an engine operate in a cycle and you have noticed once this cyclic process is taken place, you can have two options. One is you can convert whole heat in your hot reservoir into equivalent amount of work. And another option you have seen, you have whole heat within the cycle, the heat supplied, and you have noticed, oh, there's a possibility to reject certain amount of heat into another reservoir. It is, you have seen. Then you have a work done also. So, second law of thermodynamics says, when engine operates in a cycle, it can't produce net work output while exchanging heat with a single energy reservoir. At least you should have another reservoir to reject certain amount of heat. Then only it become realistic, even with the definition of theory. Okay. So if we come up the second law with another words, we can express or we can state like this. It is impossible to construct an engine working on a cyclic process which converts total heat into equivalent amount of work. It is impossible to make heat engine which operates in a cycle converting whole heat or total heat into equivalent amount of total work. That is what second law says simply. Then next we will study about these relationships with this. Heat belongs to hot reservoir and heat belongs to cold reservoir, and the work output that could be done in the next. Okay, now it is very easy to understand second law of thermodynamics using these diagrams. You can see in the first diagram, you can see hot reservoir is there. The Q1, the amount of heat is supplied. Then if you have taken W, the amount is W, then you can't say if this Q1 is equal to W, if you can make such an engine, it is impossible. That is what second law says. So in this case, you are sharing with only single reservoir which is hot. You are not rejecting to anywhere. So you have only single reservoir. That's why earlier it says that it is impossible to convert whole heat into whole work while sharing with a single reservoir. So this is your single reservoir. And this is your heat and this is your work. And second law says it is impossible. Then from this diagram you can understand what second law says. Then what is possible in a heat engine? So this is the next diagram. You should have a hot reservoir and you should have a cold reservoir. The rejecting certain amount of heat. And balance you can take as work output. Then W is always less than, W means your work output is always less than heat supplied, which is Q1. W is less than Q1. So rejected amount is Q2, supplied amount is Q1. Then your work output W is equal to Q1 minus Q2. Then you can see this satisfied the first law of thermodynamics. What is first law says? First law says sigma q is equal to sigma w, or sigma w is equal to sigma q. Then you can say that means when a system is taken through a cycle, when a closed system is taken through a cycle, the net work done is equal to net heat supply. So the same thing you can observe here. Net work done is W. It is net, only W. Then net heat supplied is to the system, to the entire cycle, Q1 minus Q2, which is sigma Q. Then sigma Q is equal Q1 minus Q2. So then second law comply with the, or obey with your first law. That means second law does not contradict first law. That is, you should study in addition. So we will study the same thing in the practical with heat pump. Okay. Oh, now we have reached to heat pump. This is to be studied as one corollary of second law. What is heat pump? Heat is pumping. You have seen water pumps. Then you have pumped water from low elevation to a high elevation using a water pump. Huh? You are not pumping water from tank to well. No. Very rare cases. So then similarly, here you are going to reverse what you have studied. Then you are going to pump heat from cold reservoir to hot reservoir. That's why it becomes heat pump. Right? Then we'll see what it says. In a system, heat cannot be transferred from a cooler to a hotter reservoir without doing work on the system. Is it clear? What it says? You can't simply supply heat from cold reservoir to hot reservoir without work being done on the system. That means you have to supply W in order to pump heat to hot reservoir. Shall I repeat it again? Yes. If you have a cold reservoir, you want to pump heat from this cold reservoir, then what you should do? You have to supply work to the system and pump heat into the hot reservoir. Without pumping heat, it is impossible. That is what you have to understood as a corollary of the second law. Yes. Then we'll read what it states. In a system, heat cannot be transferred from a cooler to a hotter reservoir without doing work on the system. Very clear with the diagram. Okay, this is heat pump. Then you have studied heat engine in the previous slide, and this is your heat pump. You can connect both. It is also possible. You will study this heat pump. There is a practical setup with this theory, and it integrates with having sharing knowledge of open systems, closed systems, air conditioning, refrigeration, about many processes belongs to thermodynamic systems. We'll do that practical later. Oh, again we have reached to the end of this session. Then this is the summary you should remember. Usually, I'm not going to read. You study yourself and remember things. Okay, you have to take care of yourself, adhere to the measures taken from the governments to reduce vulnerability with this serious virus, spreading virus, COVID-19, until the mitigation is completed. Take care of it. Important thing, you should remember what you have studied. Take care. Have a good day.